Yes, dear friends. Actually, I want to tell you something about conductance and conductivity. So, reciprocal of resistance is called conductance. Therefore, conductance equal to 1 upon R, and hence SI unit of conductance is ohm inverse, or some people call it Mho. Okay, it is Mho. And reciprocal of resistivity or special resistance is called conductivity. Sigma से लिखते हैं इसको इक्वल टू 1 upon rho, and therefore its unit SI unit of conductivity. Is ohm inverse meter inverse. Sometime in exam you may be asked dimensional formula for resistance and resistivity. Dimensional formula for R resistance. R equal to V upon I, and V equal to W upon Q into I. Dimension of work ML2 T minus 2 and it is Q8 ampere square T, goes to equal dimension is IT. है भाई, तो और एक आई यहाँ पर. So dimension formula for resistance become ML2 T minus 3 A minus 2. These things are also asked in exam, and similarly conductance it will have dimension formula M minus 1 L minus 2 P3 A square. Now resistivity and conductivity. So rho is equal to RA upon L. Just now you have written dimension bar as ml2t minus 3a minus 2 into area again L square upon L, so L बच गया. So it is equal to here ml3t minus 3a minus 2 dimension formula. Actually all these things come from practice. If you keep on doing practice, so you will get all things easily. अब ऐसी बोल resistivity conductance sigma, so it's very simple, m minus 1 l minus 3 t3 a2. So keep on doing this practice also. Here my aim was in this video dependence of resistance and resistivity on temperature. Dependence of resistivity or resistance on temperature. The resistance or resistivity of different materials depends in different manner on temperature. I mean, I'm telling you the resistance or resistivity, or resistance of different materials depends on temperature in different manner. By conductors are those which allow electric current to flow through them, and I told they offer resistance. Why? Because in case of metallic conductor there is a big number of free electrons, and when they move they collide each other. Due to collision their motion inside conductor is opposed. So in case of metallic conductor, in case of metallic conductors, the resistance and hence resistivity increases with the increase of temperature almost linearly at low temperatures. At high temperatures, this linear dependence is disturbed. At high temperature, this dependence, this linear dependence, the linear dependence is disturbed. Actually, rate become high. So at low temperature, low means not about 10, 20, nearly up to 100 degrees centigrade. RT equal to R0 into 1 plus alpha T minus T0. Resistance of conductor increases according to this equation, where RT is the resistance at temperature T. Similarly, rho T is rho 0 into 1 plus alpha T minus T0. Here RT and R0, RT and rho T are the resistance or resistivity at high temperature. T and R0 and R3, rho 0 are the values of resistance and resistivity at low temperature, at initial temperature, For reference, we take at 0 degree or room temperature. We will take in also. Alpha here. Alpha is called temperature coefficient. Coefficient of temperature. Temperature coefficient of resistance. Alpha. From this equation you can write alpha as, here alpha is also given as RT minus R0 upon R0 into T minus T0. Therefore, unit of alpha means temperature coefficient of resistance is per Kelvin by ohm cancel per Kelvin. The temperature coefficient of resistance for alloys temperature coefficient of alloys. Alloys, you understand, which are obtained by mixing different metals and non-metals together. Temperature coefficient of resistance for alloys is much lower than metals. Metals have high value of temperature coefficient resistance, and for manganese alloy, ये भी एक alloy है, alpha has the lowest value. You are given in table. I show you the table. We keep your NCERT book with you. Here it is a table in which you are given the four metals. The order of alpha is for silver it is 0.0041 per degree centigrade, while for manganese it is 0.000. For manganese it is 0.002 into 10 to the power minus 3. If I write this in power of 10, 4.1 10 to the power minus 3. और इसको लिखोगे ऐसा तो 2.0 10 to the power minus 6. So 1000 times less. Here this is table on page 102, table 3.1. Please study this table. So alloy manganese has lowest value, very much low value, or almost we can say the resistance of manganese does not increase significantly with the rise of temperature, and that is why in a lab you will see, if you get the chance, nowadays it has become a custom that teachers and school do not provide period for labs. It is very unfortunate. While doing verification of Ohm's law, जो हमने कंडक्टर वोल्ट मीटर के वो लगाया था होता है Ohm's law में, ये कंडक्टर लगाते हैं, ये मैग्नीन वायर का होता है, इसका होता है मैग्नीन. Why do we use manganese? Other wires of copper, conducting wires copper है it is your state. So why do we use manganese wire? It is plus minus ammeter, voltmeter. So manganese क्यों use करते हैं? We use other devices like meter bridge, potentiometer. There also we use manganese because manganese pass current, temperature certainly rise, and then V upon I graph will not remain straight line. While our aim is through Ohm's law, I told you ohmic circuit are those in which Ohm's law is valid. So in case of manganese, this resistance does not change, almost it may come straight line. Similarly, potentiometer and meter bridge, we assume that resistance of device remain constant. So, but for every material, when we pass current, conductor gets heated. So manganese wire has no sufficient increase in resistance after heating. So we use. ठीक है भाई? In case of semiconductors, in case of semiconductors resistivity decreases with temperature exponentially with rise in temperature. Why it is so? In case of semiconductor, free electrons are small. When we increase temperature, number of electrons increases, which increase the conductivity, and hence conversely we can say conductivity increases, and hence conductivity of semiconductors increases with the increase of temperature. So the behavior of semiconductor is just reverse that of metals. In case of insulator, at high temperature the conductivity again increases, because due to ionization, when we raise temperature of insulators like so ions are produced and that can increase the conductivity. Now if we compare the resistivity of metals like copper, rho and T, the graph comes like this. So at low temperature it is almost line. I dictated there almost linearly at low temperature. In case of nichrome is an alloy. Resistivity and temperature increases slowly. That linear part remains there. In case of silicon, P and rho, silicon is semiconductor. So resistivity decreases like this. Sorry. As we increase temperature, the resistivity of silicon decreases. So you can compare graphically the dependence of resistance and resistivity. Thank you. We'll meet